So hello everyone, welcome to the Cruising with Carlo workshop. For those of you who don't know, I am Lorian. I'm the software lead for the ESDC, or the Edison Self-Driving Car team. With me is Peter, he's the president of the team, and Darsh,
Hi.
representative from CSOC.
Hey, everyone.
So welcome. Let's first give a little overview of what we do at the ESDC. So we are a self-driving car team that is dedicated to making a self-driving car to help more disabled students get around campus easier. So this was started, I think, it was started last year by a student named Rafid Dewan. And I think Peter was with Professor Atia as well, right?
Yes, Professor Atia was one of the leading professors to get the project, and he's still helping us out now.
Yeah, big help from Professor Atia. So it is known within the school as the Carleton Autonomous Vehicle Initiative, or the CAV initiative. And again, we're creating this car to help disabled students get around campus easier so they don't have to walk everywhere. So our team is mainly divided into two sections right now. So we have the hardware team that is dealing with all the things that are going to directly interact with the car. So we're currently looking into drive-by-wire options such as Signal, and we're hoping to process those signals using a Raspberry Pi. Peter, if you want to send the link in chat to Signal Auto, because Signal's a cool little thing where you plug that little chip in the top right there into your car, and you can essentially drive a car using an Xbox controller. It's really cool. Thanks. The other division of the team right now is the software division. So we're dealing with Carla, and we're also responsible for the website and just everything software related. So we're going to be doing a bunch of machine learning stuff, simulations, sensor arrays, you name it. So why do we use Carla? Well, Carla is a free open source software that is very robust, as you'll soon see, and it's going to save us a lot of money by not crashing a bunch of cars. To get started with Carla, we're going to go over some of the hardware requirements. So in order to run Carla, you do need a bit of a beefier system. So minimum, you want at least a 4-core 8-thread processor, at least 4 gigabytes of video RAM, 6 is better, and 16 gigabytes of RAM if you're running on 8 or anything below 16, it's not going to be a good time. Ideally, you'd have about 8-core, 16-thread CPU. Even better if you have a 16-core CPU, but those are obviously pricier. For a video, you need at least 6 gigs. 8 gigs is ideal of video memory. And for actual RAM, it's best to use 32 gigs. Even on a desktop, this simulator will run very hot. And so I do not recommend running this on a laptop. Also, on top of everything, you need about 200 gigs of storage for everything included. So included, we have Visual Studio and Python and Unreal Engine. And this simulator isn't actually compatible with Mac. It's ideally made for Linux and works obviously on Windows. There's 2 different installation processes we'll see in a second. So the first thing you have to do is you have to clone the Carla repository, their Unreal repository, and get that all set up. So you run the setup, you generate the project files, and then you have to open up the Unreal Engine 4 solution in Visual Studio. So that's why you have to install Visual Studio. And then you have to build that solution, which can take a long time, 30 minutes to an hour, if not longer. And then you have to clone the Carla repository, and you have to build that. And then you should be good. You have to build some of the Python API and whatnot. So in order to launch Carla, you have to go to the Visual Studio command prompt, not your usual command prompt. And from there, you have to change directory into your Carla folder, and then you have to launch the actual thing. So here is a brief overview of what Carla looks like once you finally launched it. So as we can see, we have the hotbar, we have just basic place actors. It looks like a basic Unreal Engine. You'll see in the top right, though, we have our actor list. And actually, I can pull up what exactly this looks like. So in this actor list over here, you can see that basically everything in this simulator is an actor. for everything from just like the lines to the crosswalks to the stoplights. There are all these things called actors, and we'll get more into actors in a second. So in order to actually start the simulation, obviously you have to hit play, or you can hit launch, up to you. They'll usually take a second to load, and then you'll be off to the races. So now for the fun part. Now we get to run actual simulation stuff. So Carla it's C++ based. However, it has the ability to run Python scripts and has a giant Python library for you to make use of. So in order to run these scripts, you have to go into the Python API directory, and you have to use the Python command to run your Python script. So the first part about learning Carla is you have to recognize that it's a server client basis. So the server is the system that you're actually running the simulation on. And that server will have a port, it'll have like a user, and all these different clients can connect to it. Connecting more than one client can be a bit of a hassle, but more often than not, you're going to be running the Python scripts from the server itself anyway. That's what we do here at the ESDC currently. So you just hit play on the server, and then you can just run your Python scripts. So, 1 second. So the first part about learning Carla scripts is you have to understand what blueprint and actors are. Blueprints are kind of like a class. When you go through a Python script, there will be a giant library full of blueprints that contain the default settings for all actors. So you'll have a blueprint for every type of car. So you have a blueprint for an Audi, you have a blueprint for a bicycle, you have a blueprint for even the pedestrians. And so you instantiate these blueprints, and then you can modify their attributes. So you can change the color of the car, you can change the car's physics, you can change the car's collision detection, you can change its speed, you can change all of these different things. And then when you create an actor, that is when you take the blueprint and you put it into the simulation itself. So, for example, you might have a blueprint for a red Audi, for example, and you've changed it so that it's red, it goes at this max speed, whatever. But then you need to run a certain command to take that blueprint and actually put it somewhere in the simulation and instantiate it. So that is what an actor is. It is the physical thing in the simulation that has been based off of a blueprint. And actor has a very broad, I guess, encompassment. So an actor can be a car, it can be a bike. However, it is also everything, anything that can be detectable. So all the lines in Carla are all actors. All of the traffic lights, all the stop signs, traffic signs, those are all instantiated actors that can have their attributes changed. So that brings us to the map portion. So the map, as you might figure, is just where the simulation takes place. And the map has a couple of different cool features. So the first one is the fact that they can have layers. So you can assign certain actors to be part of a group that is called a layer. So example of these layers might be like a building layer. You might have several traffic sign layers, or several traffic signs in a layer. You might have all the lines on the road be part of a layer. And so this allows you to access groups of actors at once. It's almost like using like a diver class in HTML or something. So again, we can also access different vehicles. So if we want to access all the vehicles at once, we can just have them in one layer and just modify that one layer without worrying about the rest of the simulation. Now, here's the fun part where we get to sensors. So sensors are also actors, but they're not exactly visible at all times. So Carla comes with a whole suite of different sensors. We have the RGB camera, we have the depth camera, we have LiDAR, we have radar. You can go through the documentation yourself. There's tons of different sensors, and they're all very, very general sensors that can be modified to fit your specific actual store-bought sensor. So how they work is when you create them in Python, they can be attached to a certain vehicle. And when you modify the position of the sensor, it is modified relative to the vehicle. It's very useful. And on top of that, whenever a sensor is called or the event is triggered, it calls a function. So you actually have to give it a function to call every time the sensor does something. Sorry. And it actually fits into a Lambda expression that it calls every time. So as we can see, we have the depth picture. So that is a raw depth picture that is like exactly what Carla returns. And then we have the RGB picture. And then you'll notice the last picture is cut off. So that's what happened when I had too many things in the background running. And this is why we recommend having more RAM. Okay, so now we're going to go over a sample script from Carla. If you'll just give me a second. Okay. So this is our sample script. We can see that we import a bunch of stuff from the system, and then you'll notice this try and accept thing in the import section. That is in order to get the proper Carla library. It should be noted that currently Carla only works with Python 3.9 and 3.8. It hasn't been updated to 3.10. So this is to make, you need to make sure you have Python 3.9 installed here. And then if we keep going down, you'll notice that we have an actor list. So this is starting to get into some of our paradigm. So whenever we create an actor, we want to make sure that we have a collection of all actors that is going to be important later. And then you'll see we're getting our client. So this is where we connect to the server and we actually instantiate Carla in Python. And then you'll notice that there's a timeout of 20 seconds. So it automatically comes with 2. This has been modified to do 20 because 2 is often not enough. It is recommended that you give it at least 5 seconds to connect to the server. And then we just have a basic, okay, the world is this is getting our world and everything in it. So that includes blueprints, includes the map, includes everything we could possibly want. And you'll notice that we're getting the whole blueprint library of every single blueprint that they have. But then in the next line, we can filter out vehicle. So we can go through, I don't have the documentation here, but you can go through the documentation and you can go through all the different kinds of blueprints that there are. There's vehicle, there's sensor, there's camera. And so this is how you get a specific vehicle. And it has this very distinct hierarchy where it'd be like vehicle.audi.a2. So it gets very specific, or you can do something general like this. And then you can choose a random one where it's like, I just want a random vehicle. And then here we can see where now that we have the blueprint, we can modify attributes. So we're getting a random color and we're assigning this vehicle to have this random color. Now, in the next line, you'll notice that we have a transform. So when we spawn in the car, we need to make sure it's in a certain place. And Carla maps, either if you make one or even better, the presets that they come with, will have specific actors on the road designated as good spawn points. So here we're just getting one spawn point just from all the spawn points that this map has. And then here we can see that we're instantiating the vehicle as an actor with the world.spawn actor. And when we spawn an actor, we have to give it a blueprint and we have to give it a transform. So we're basically saying, okay, you're going to spawn an actor. It's going to be an actor from this blueprint, and we're going to put it here in the transform. And then we add that vehicle to our actor list, print a little message. This autopilot, obviously you won't always use it, but it is very useful for just like, okay, we just want the car to drive around random places and we're going to collect some sensor data. So this might be useful for example, if we're trying to train a neural network to detect traffic lights and what state that traffic light is in. We might just set the autopilot and then get a bunch of RGB images whenever the car is stopped. So useful little feature to have if you just want it to go around. And then here we have our first sensor where we're getting a depth camera. And we set the transform to be just this little bit of an offset. And then you'll notice when we spawn the actor, we can give it this optional argument to attach to our certain vehicle. So now this transform location is relative to that vehicle instead of relative to the world. And then again, we add the actor list to the camera, or we add the camera to the actor list rather. And then again, just, okay, we added it. So now we get on to some of the more sensor specific stuff in the tutorial. So for this camera, we need a certain color converter, because otherwise we're going to get that ugly image that was all green and red and whatnot. So we're going to add this color converter, and then we're going to do this camera.listen. So this camera.listen, whenever the camera tick goes by, it will call this function. So we're going to save to disk, and we're going to do this path, and we're going to give it this name as well. And this CC is the color converter. So we give it the path and we give it the certain image conversion that we want it to do. So this will just continuously save pictures. And then we can take our vehicle location, and if we don't like it, we can just add to our X a little bit. So it's hard coding where our location is. And then we can drop it down, we move the vehicle. Again, we're just changing the location of a vehicle. And the reason we're doing this is because we're going to spawn in a bunch more vehicles. And we don't want to have them all spawn in the same place because then they crash. So we're going to offset them a little bit. And then we're going to add a bunch more. And then again, we're going to spawn them in. And we're just going to configure them all to the same type in our loop. And then this time.sleep here, that's how long we're running the simulation for. So this particular simulation is only going to run for 60 seconds. It's just a little demo. And then here is where our actor list can come in handy, because we want to destroy all actors at the end of the script, because otherwise you can end up with memory leaks and just simulations never leaving the proper state. So we destroy all of the actors. And so this is very convenient when we have all the actors in the list, because then in Python, you can just go through each of the actors in the list and destroy them individually. So let's have a look at this in action, shall we? Just give this a second to play. And then I can show you this is where, okay, there we go. So I can show you exactly how we can run a script. This wants to run. And this is why we recommend more than a 4-core processor, because of just how long it takes to simulate stuff. There we go. So see, I can move around in the simulation here. And then we're just going to zoom out a little bit before we spawn in all of our vehicles. Okay, now we have a good view. And then we can just run this simple command. And you'll notice we now have vehicles moving on the road. And you'll notice that they stop at traffic lights. They stop behind each other. When autopilot is set, they just behave like normal ideal vehicles. We can just follow these guys around for a little bit and make the proper turns. And so this is just like very base of what Carla can do. See, we even have a guy on a bike. Like there's a ton of different vehicles that we can spawn in. They'll keep to the proper lanes. And we'll notice as well that you can't see it here, but all of these lines are set as waypoints. So the lines themselves are just textures and don't actually mean anything. What we have to do is we have to assign an actor to each part, and those are called waypoints. And those give the vehicle the information they need in order to stay in their lane. And then we can see that there's this mesh here that outlines an intersection. And just everything that gives information is an actor. It looks like our little simulation is done. Yeah. So you see we've destroyed all actors. There's nothing left on the road. And if we want to look at this, so we have some basic paradigm. I'll go over one of our scripts that kind of outlines this better in a second. So we have all of our actors go in a list. It's better to create sensor functions. So you'll notice in that tutorial how it was just set as a Lambda function and the function was created inside. Where is it? So this line here, when we do camera.listen and we're doing Lambda image save to disk. So this this here is our Lambda function. And I think we're going to try to avoid that. So instead of having that, we're going to have an explicit function that we're going to call every time. And I'll show that right here. Scripts. 1 minute. There we go. Okay. So here is something that we've created. All of that tutorial script actually comes with Carla. So it's just like almost a baseline test to see if Carla runs properly. So here we have a bit more of our paradigm visible, where when we connect to our world, we want to have it in a function just so that we can take that connect function and bring it into anything we want. And then, so we have our blueprints. We want to, when we want to initialize our cameras, again, we put that in its own function so that it's not just one long script. Get our transform. And then you'll notice that when we use our camera.listen, we are giving it an explicit function to call every time instead of creating the function with, as a parameter. And so that can be useful just for clarity and just for more consistency. As well as you'll notice that in our connect, we are setting the timeout fairly high. Honestly, 5 seconds is probably enough, but 2 seconds that Carla comes with is often not enough. So it's good to give it a little bit of headroom. So we're trying to make it as modular as possible. And then of course, at the very end of the main script, you want to destroy all actors so that you don't have room for memory leaks. So now we get to see some cool examples of what Carla can do. So if you'll give me a second, I'll go back to Carla. And we get to create, we'll go with the Open 3D LiDAR first. So this gives an example of how the LiDAR works in Carla. Let's give it a second. And there we go. Here we just have a LiDAR outline of a car going. So the way this works is it gets a series of points from the LiDAR, and we convert that into actually a NumPy array. And then we can display this array using NumPy. And just gives this cool little simulation of what the LiDAR sees. And so this would be useful on an actual self-driving car because this helps detect, you can actually see a visible outline of all of our surroundings. Okay. Unfortunately, this doesn't like to shut down properly, so we're just going to kill it. There we go. Okay, our next example is going to be just a basic demonstration of generating traffic in Carla. Oh, might have a bit of a technical difficulty. Looks like Carla might have crashed. Let's see. Can I go back to the 3D LiDAR? Okay, so there's the LiDAR again. Okay, we can still do that. Okay, close it. Sorry for the technical difficulties, everyone. All right, let's try to run the generate traffic. Okay. Yeah. It looks like the simulator has in fact crashed. Well, that gives me the opportunity to show you how to start the simulator. So we're just gonna kill that. Okay. So here you'll see that I am I'm in the current Carla directory, and then I can just run a quick make launch. So we can take this opportunity to go over some of the scripts more in detail. If we just want to go examples, and then we have the Open 3D LiDAR. So as you can see, this one gets a little bit more complicated in terms of how it works. So we have our LiDAR function. So every time that the LiDAR triggers, we're going to be calling this function. And so you can see we're taking that raw data and we're putting it into a NumPy array. And we're just modifying the intensity so that we get a spectrum of the intensity. That's how you get the color coding. And then here you can see we're getting all of our points, colors, and this is a different kind of LiDAR callback just for two different types of LiDAR. Here is our LiDAR blueprint. So this is just setting up the LiDAR for the attributes that we want. So you'll notice that whenever we set an attribute, it actually takes two string arguments. So the reason for this is it is the equivalent of going into Carla and just filling out like two text boxes with what you want. Here's just more configuration stuff. Main, we're getting our settings, getting our traffic manager, just a bunch of LiDAR settings. But yeah, this is obviously a much more complicated version to get just that cute little animation of the car going around. And then here you can see that we have an argument parser so that we can actually change different aspects of the script from the command line. So our default port, whenever we connect, if we're on the server and running scripts off the server, we just we use the localhost and port 2000. And we can see we have all these arguments. And if we want to look at the generate traffic, you can see again, get actor blueprints, generate them, another argument parser. And then basic configuration, we get our vehicle list, we're getting a walker list because we can generate pedestrians as well. And obviously we're going to get the world. It comes with a traffic manager. We get our world settings. And look at that, Carlos back up. Fantastic. So we're just going to finish up with this. So you'll see here, this is all of the different blueprints we're getting. And we're sorting them, spawning them. And we're spawning them all, setting them all to on autopilot. And we're transforming them to their proper spots. Hopefully now that this is back up, we'll be able to get a better idea of what's going on. So again, just give it a second to start up. Okay, and now we can go back to this and do Python generate traffic pi. And here we go. We've just spawned a bunch of different vehicles. So as you can see, as cool as this is, it is fairly complicated just to get something as simple as getting a bunch of cars on the road. And like, there's a lot of structure that needs to go into it. So when you get into even more complex things, that there is a solid structure that you can rely on. And this should only run for a little bit. Okay. So then if we want to end this script, let's see. Okay. Now for our next script, we're going to get something really cool where it's going to go to a pedestrian. So if we want to see a pedestrian, just give it a sec. So here, even though Carl is meant mainly for cars and self-driving simulation, it can very easily simulate a person walking on the street, even if their behavior is a little irregular. Look, they don't even stick to the crosswalk properly, just like real pedestrians. Okay. And then we're going to get a demo of how we can actually see sensors and get a visual feed. I'll pop this open. Should get a nice visualization. Yeah, there we go. So see, it plops down a car, and we can see like front view, more narrow FOV, and we can see this LiDAR going. I guess we're at a red light, so it doesn't want to go. There we go. So here we can see multiple different sensors in tandem. So you'll notice that the top part that's one camera here, one camera here, one camera here. LiDAR looks like we actually have our rear camera here and another LiDAR. So this is a nice, cool thing just to get an idea of the whole scope of what a self-driving car needs to be able to see in order to get full functionality, because you're going to need to see everything and be able to sense everything in order for this car to go. And so for our last kind of demo script, we're going to basically turn Carla into GTA 5. Oh, whoops, that's the wrong command. What's that? So it puts it into a little window here, and then we can full on just manually control the car. And here we can change the weather. We can change our speed. You can see in the HUD here that like what our throttle is, what our steer is, and this is all just using WASD like a normal video game. So it's just like you get to drive around, and using this, you'd be able to put sensors on, and you'll notice that it updates line. You can cross line the broken line. You can cross the solid line. And so the reason that it knows this is, once again, because of those actors acting as waypoints, that it basically goes, okay, I've touched a waypoint, I've crossed the broken line. So this is a really fun thing that you can do. All of these scripts that I've shown you actually come with Carla. So if you download Carla, you'll be able to do all of these and run all of these. Okay. Okay, so now that we've seen all of these example scripts, I'm going to give you guys the opportunity to kind of create a script on your own. We're going to go back to the tutorial. And if you guys want to follow along, if you want to open up your Python editor, we can create a quick Carla script and see if you guys want to run it. Oops. So we're going to go to examples, tutorial. So here's the basic of what you need. I can actually post this in chat if you guys want. So that is the very basic of what you need just to import the library. And if you guys want to create a script with me, then you can send it into the Zoom and we can try to run it. So we need this client localhost. And then you need to set the timeout. You need a main. You need the blueprint library. You need a filter out for the vehicle of your choice. As well as I'm going to quickly send you guys the documentation for Carla if you want to do this just on your own. But you can see how we have timeout, we get our world, we get the blueprint library, we get our filter, and you can check the docs as well. I'll see if I can get you guys a list of all the vehicles. Blueprint library, sensor. Okay, so here we have the blueprint library as well in chat. So if you go there and you go to the vehicle section, you'll see all the different vehicles that you can spawn in. So instead of this random.choice, you can actually do blueprint library.find, and then you can give it a string representation of the vehicle that you want, and it'll spawn in that specific vehicle. And then you can see here, along with the vehicle, you can see all the different attributes that it has. Obviously, only some are modifiable because you don't want to modify the number of wheels. The main fun one to modify is the color. So you can change this to like green or red or black or whatever.
I guess for people who don't have like the library installed or like, you know, any kind of Carla stuff involved, like, can we just like, I guess, offer suggestions in the chat and then?
Yeah, sure. So I know like, even if you don't have the Carla library, if you just type in its syntax in like a Python script, and if you want to send it to me, I can run it for you guys.
Cool.
But obviously it is a lot to get your head around in like 30 minutes.
Maybe I feel like
But-
something that might be easier is like kind of maybe like, try to come up with a scenario together and then try to just program it, I guess pair program it with yours queen.
Okay.
That way, it will be a little interactive and people kind of have their
Okay. Sure, let's create a script together. Okay, so let's start with what I put in chat, where we just import a bunch of stuff. And then if we swap back and forth, we can see we need our client is equal to Carla.client. Oops, not 3000.
Can we spawn like a pedestrian right in front of a car and then see,
Sure, we could try.
see if it reacts as we expect, something like
Let's
that
see.
on autopilot?
See if it allows us to, and then we'll do, we're just gonna copy and paste this main,
Yeah,
just because it's a lot faster. So
I'm not sure if you need the import time there. That's something.
Yeah, you don't. That was mainly for the timeout.
Okay.
So we can see if we want to, if we do Walker. So we can do all this, and then we can do Walker is equal to, what do we call it? I think we called it the blueprint library. Yeah. Blueprint library dot filter Walker. And then we can do, we have to make it a random choice, right? And then we can transform it. So actually we can do, what should I call it? I'm just gonna call it A Walker is equal to, what should I call it? World dot spawn actor. And then we can do, no, we don't want transform. We want to just modify it a little bit so it's in front of the car. So we want to make the transform. Yeah, you need to, yeah, it's basically this. So we're going to take this base template. We're going to do Walker transform is equal to Carla. And then instead of modifying it in the Z, we're just going to modify it in the Y or in the X. X is equal to, let's just do 10. And then we're going to spawn it with the Walker, Walker transform. And then to make it relative to the vehicle, we can do attach to is equal to vehicle. And then actually, this is where we do need time because we want to because we want to just do the simulation for a little bit. So we can do time dot wait. I think it is time dot sleep. My bad. Time dot sleep. We'll just run it for 5 seconds. And then we want to do vehicle dot Wait, no. Destroy. Yeah. And then we want to do a walker dot destroy. It'd be better if these were in a list, but just for sake of doing it immediately. And then we want to do if main to main. And then we want to do just main. Okay, and hopefully this will spawn a pedestrian right in front of a car.
I think you have a typo. Line 69.
Oh, do I? Oh yeah, right here. Now the only problem I can see with this is we don't actually know where the car is going to spawn. However,
Can you set that too, or is that possible? Just
there is a way to set it. I think if I go through the actor list, you can do spawn point. So we'll do spawn point 149. Actually, I don't actually know how to set the designated spawn point, so this may not be completely visible. So we're just gonna try and look for it. First, see if the script runs. Oh, it looks like you can't spawn it right in front, unfortunately. So collision at spawn position. I wonder if I modify the X to like 100, if it would run. See? Oh, it looks like I ran it, but we can't really see it. So it's unfortunate that we can't really see it, but this is the gist of how you would write a Python script for Carla. And I believe that brings us to the end of our little workshop today. So if you have any questions, feel free to come on mic. And as well, we have, whoops. We have our Discord for the ESDC for anybody who wants to join. Please feel free. We're always looking for new members.
yeah. Thank you, Lorianne. That was amazing. That's really cool. Does anyone have questions? Anything they want to share?
Thanks, Peter, for the Discord. So feel free to click that link and come join the club.
I have a question.
Yeah.
Like obviously it's software, right? And I feel like the amount of errors or unpredictability is pretty low. And is there a certain way you can set that in a sense of like, is there a way to instill a sense of randomness to the simulations, I guess is my question.
I would say yes, because obviously during all these simulations, we had autopilot turned on, right?
Mm-hmm.
And autopilot already has an inherent sense of randomness because the path isn't really set. It will just kind of choose a path on its own. So for example, that generate traffic.py just spawns like 30 vehicles and they're all just going on the random way, right? So we might run that, and then we might have our own car that has its own navigation system that we created. And it's like, okay, navigate around all these 30 different vehicles, all taking random paths.
Interesting. Okay.
Mm-hmm.
Cool. And so about the philosophy of like, I'm curious how this workflow works and if there's multiple workflows as well. of like, from what I can see, like, I guess one of the biggest workflows of this software could be like, using the software to kind of collect data by,
Yes.
driving the car around or just putting it on autopilot and seeing what kind of data comes. I'm curious, how do you use that data in the first place? And is there other ways of using the, software as well? By, I guess you could also test it, test your autopilot, your own autopilot system. But I'm curious, like what kind of workflows are there, and then how you use that data in later
Right.
on.
So
Yeah.
actually, that reminds me, there's an example I left out on it if people want to see it. But basically, what we can do is we can collect RGB images and we can figure out when the car is stopped. So we can just like take pictures of stoplights, right? And then I think in the future, we're going to use that as the training data for a neural network to try to identify. It's like, okay, here's a traffic light. Can we go? Do we need to stop? Is it like a left turn signal? What have you. So if we actually want to see my own script, we can do get sorry, Python get pictures.py. What? 1 second. Oh, there's no underscore. My bad. So this is a script I wrote myself, and what it does is it will actually just collect photos and put them onto my hard drive. So you'll see I have a bunch of these different photos all time-stamped. You'll notice that a lot of the RGB pictures are cut off. Once again, that's from my lack of RAM, because I'm currently screen sharing, running Carla, running a presentation, what have you. This is why we recommend 32 gigs of RAM. But as you can see, this is how we can collect data in order to run through a neural network. And so in the future, we're actually getting a server to run this on at Carleton. And so we'll be able to just like, okay, just leave this on for like a day, collect a ton of data, put it onto a drive, and see if we can create a neural network to process it.
Interesting. Really cool. Wow. Yeah, that
And then
makes
obviously the other, I guess, workflow would be just like you said, collecting sensor data. So it's a lot of back and forth with hardware about like, okay, what sensors can we get and where are they going on the car? And then plugging them into the simulations like, okay, theoretically, what are they going to be able to see? And then it also goes the other way around. Like, okay, we found this really cool sensor configuration. Can we get that working in hardware? Yeah, definitely a lot of stuff you can do with this.
Mm-hmm. How close does it get you to like the real deal in a sense, right? Like, I'm just curious. I don't know. This is kind of a, I guess, weird open-ended question, but I guess
Unfortunately, I don't have a great answer because we don't actually know the real deal currently.
That's fair. That's fair.
We're currently working on getting a car. But I like to think that it's fairly accurate.
Yeah,
Otherwise, that's 200 gigs of my SSD gone.
This could be, yeah, as mentioned in theory, can get us, it allows us to basically do beta testing on our software. So without the risk of putting, $10,000 car and $40,000 drive-by-wire kit and all the hardware at risk, we can run simulations using Carla with our scripts, as Lorianne mentioned, and just work out a lot of the big and obvious bugs, so that once we implement it onto an actual vehicle platform and we do this, like make it drive in a straight line, it's less likely to do a U-turn and drive into a hydro pole or something.
Gotcha. So you guys said that you guys are making, trying to make like the map of Carleton to get, obviously this thing working. I'm curious, how you guys are planning to do that? How far in it are you guys? And yeah, I have no idea how you map out Carleton.
Currently there hasn't really been work on it because it's not our first priority right now. Our first priority is kind of figuring out Carla, all of its capabilities, and getting an actual car and trying to map the simulator to the car itself and getting the car moving. When we actually do get around to it, it's probably going to be a lot of copy and paste from assets. Going to be learning a lot of Unreal. Probably a lot of stand-ins. So we're not going to map the building specifically. It's probably just going to be blocks as buildings. Just like, okay, the university center is this big. We just need a building that big. It doesn't need to look like the university center. Other than that, just like laying down roads, because I think with the roads, they have like length properties and stuff. So it's honestly, probably don't even need the buildings themselves. We just need the roads. And I know Carla actually has the ability to just export roads as their own file, almost as like a CSV or something. But it's like a specific library called like, what is it called? It's like Open Drive, I think, that has its own file format for roads. So probably gonna be looking into that.
Interesting.
Yeah, the process that was started last year on this that unfortunately fell through was to utilize basically Raspberry Pi cameras stuck to the top of a vehicle and drive around on every possible road to record data, and then using that to implement, all right, what does the vehicle see, and put an object there. Because as much as the vehicle needs to know the roads, it's very helpful if it has a building that you can flag as a reference when we're going to be having it driving on a closed circuit loop. Right, so it knows when it reaches, I'm just trying to, I don't know, if it sees Dunton Tower, right, it can reference where it is roughly and all that.
Really cool. Yeah, definitely sounds like a lot of thought needs to go into it, and yeah, that's awesome. Really cool project that you guys are working on.
Thanks. If anybody in the audience has any questions. Otherwise, I think that's about it. Thank you all for joining me. Feel free to join our Discord. We're always looking for new members. Peter, you got any closing words?
Yeah, sorry again. Yeah, thank you guys for showing up. And if you think this was interesting or cool, or just you want to get future news updates, yeah, feel free to join our Discord. We are still a growing team. So as we next year and the year on top after that, we'll be getting into hopefully more interesting, bigger projects as we get more people, more resources. But yeah, thank you for your time and thank you for showing up.
Awesome. Thank you everyone for coming. Yeah, this is a great workshop. Thank you, Lorraine, for hosting it.
Yeah, thank you, Darsh and CSOC for having us.
No, it's our pleasure. So no, thank you. Thanks everyone for coming. Have a great Saturday.
Hope to see you in the ESDC.